Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Our next presenter is Alex James.
That's me.
I want to take a minute to say thank you to Alex James. Look at the screen.
Wow. I need a better picture.
So at Microsoft, we send something called kudos to our peers to recognize their help. To help us to advance our own agenda, for cross-group collaboration. And I sent you a kudos last year, I think. But it's like, usually when they receive a kudos in email, unless the recipient tell everybody, nobody knows. I want to publicly say thank you, Alex, for helping us and work out this collaboration, OData-based environmental informatics framework. And here's a physical kudos, a four-step paradigm book signed by Tony Hay, our VP.
Oh, cool.
This is the book that, we're inspired by the things that in here about data-intensive science. Thank you.
Thank you very much. Well, I don't know. There's this show in England called This Is Your Life, where they come out with a book and then they go through everything. I feel a little bit like that, but I wasn't expecting that at all. So can you flick the thing?
Is it 2-2?
Yeah, 2 and VGA. Okay, so hi everyone. My name's Alex. I'm a program manager on the OData team. And today I'm going to talk to you about the OData protocol, or the Open Data Protocol. And here's kind of the overview of what we're going to talk about today. I'm going to give you a quick introduction to OData. I'm sure a lot of you have already heard about it or know a little bit about it, because I know Jan and I have been talking about it for quite a while. Then I'm going to give you a kind of a real-world demo of, Jan gave me some a CSV file with a whole load of element data in it. Okay, so like it brought me back to my chemistry classes when I used to be at school and stuff, and it's like, okay, so here's the periodic table. And I'm going to take that CSV and just kind of turn it into an OData feed. Okay, so that's kind of like our real-world demo. Now, there are probably better ways to do this, but it's kind of just showing you what you get if you do that. Then I'm going to, once we've done that, which is probably going to be the bulk of the talk, we will do a quick introduction to OData v3, which is the updated version of the protocol with a whole set of new features which actually really help in eScience, I think. So, and then we'll do a wrap-up, and then if there's any questions, we can go into that. So what is OData? Imagine I have a data source somewhere. This is a little database little icon there, but that could be any data source. And I want to get it out to some consumer of that data. If I put an OData service on the top of that thing, then I have immediately enabled HTTP access to that data. So the most predominant way of accessing and talking across a network today is HTTP. So OData works natively with HTTP. But better than that, I have reach across a whole plethora of devices and platforms. So I can get my data from the biggest mainframe computer sitting in some box somewhere, chucking on data, all the way down to the smallest, most tiny little handheld device, a mobile phone or something like that, and across all sorts of different platforms as well. So I can go from say iOS, Windows Phone, .NET, PHP, any of the programming languages that people are familiar with, JavaScript. So that's pretty cool. OData has this, I don't know if you can read this because it's quite small and the font's a little bit funny, but that says metadata in there on 2 lines. So not only do you expose the data, you actually tell people what the data's about, which is kind of useful. Like it's not great when you kind of hit a data feed and it just got this great big CSV file and you're like, well, what does column 55 mean? It's got some random string in it, but you don't know what it is and you don't know how to interpret it. So we have metadata as well. We support multiple formats. We support Atom and JSON. And Atom, for those who don't know, that was kind of like RSS was this format that came out for doing blogging, right? And then someone came along and said, well, you know, RSS has got all these problems. So they came out and produced Atom. And then, which is a kind of an evolution of RSS. It's a little bit better. And then they kind of got to this point where they realized, okay, Atom is great for kind of consuming a feed of data, but what if I want to update that feed? And that's where a standard came out called AtomPub, which is a publishing protocol which builds on Atom and allows you to manipulate it. And it's actually kind of one of the sort of foundations of the OData protocols. We kind of leveraged the ideas in there and then took them a little bit further and made them better for not sort of kind of news article style data, but actually for just data in general. So we've got this Atom, and then we also have got JSON, of course, and JSON is fantastic if you are targeting any kind of HTML kind of client. Right? JavaScript can just consume that so easily. It's a joke. You don't need a parser. Like, it's all in the libraries and in the browsers that you use today. OData defines a set of clear semantics on top of the data that's exposed. So if you do a GET request to some URL, which is part of an OData service, you are attempting to retrieve a resource. It's pretty much what you would expect with standard HTTP. But the other verbs are kind of lined up with HTTP standards as well. So in this case, the second example there says post to elements. What that's saying is, hey, I've got this collection of elements, and I want to post a new element. So like, I've made a great big discovery. I found this new element, and I'm going to post it up to the elements collection. Delete, well, maybe we can't find an element anymore, so we just want to remove it. No one can find that. And put would be, okay, that element, some data that we have about that has changed. We want to update it. Now, you can do kind of two times of update. You can do a put, which is kind of full replace semantics. That means whatever was there previously, I'm replacing the whole thing. So if I don't provide you a value, that means it should be null, essentially. Or you can do kind of patch semantics, which is there's another verb that we allow, which is patch. It's a relatively recent HTTP standard, which means anything that I'm not providing should be left with its original value. We also have a series of URI conventions. So if the metadata told me that elements was a collection of element objects, and each of those element objects had a relationship to a collection of compounds that you could, that involved that element, then our conventions say that, if you identify a particular element, in this case hydrogen, then if you went / compound, you'd be getting all the compounds related to hydrogen. So there are a series of conventions that OData, not mandates, but suggests. Okay, and we're doing some things with the protocol to make those more discoverable. We also have a query language. So from the metadata, I know that each element has a type. So I can now filter the elements and say, well, I'm only interested in the elements which are noble gases. Okay. Now we have a query language which covers not just filtering. You can also narrow the number of properties that you want for each of your elements. So, for example, if I know that elements have 10 properties, let's say, in my particular data source, and I'm only interested in like the name and the symbol, then I can just select those two columns using a $select operator. And you can also do ordering and order by and top and skip. So you can do paging if you need to. You can kind of, for example, you can skip the first 100 records and maybe get the next 9 or something. It's up to you. So what does this mean? It means that OData builds upon standard HTTP verbs, which is pretty important. And so, we're using the correct verb at the correct time. So if you want to retrieve some data, we're using get. That's pretty obvious. If you want to update some data, you can do patch or put. If you want to delete data, it's a delete. So pretty much what you would expect from HTTP. We also leverage standard HTTP status codes. So if you're familiar with the HTTP standard, you'll know that, like, if I try and address a resource and that resource isn't there, I should get a 404 response. And that's what we do. And that's what OData says you should do. We use standard HTTP headers. So we talked about the fact that OData supports two formats. Well, imagine that you are a client that needs the results to a query in JSON. The way we do that is we use the standard approach that HTTP does for that. So exactly the same thing that your browser would do, which is to add an accept header to the request that says, I accept application/JSON. And so then the server would say, OK, I'm going to format my results in JSON. So we talked about the standard formats. We also have kind of like the standard interactions. If we're dealing with a collection and you do a post, that implies you're inserting into that collection. If you have a single item and you do a delete, that implies I'm deleting an item. On top of that, though, we add a flexible query language and metadata, and those are the two things which make it better for data. All right. So why would you use OData? So if you've got some data you need to expose, there are all sorts of alternatives that you could use. Imagine you went off and tried to create a custom REST API. Does everybody know what REST means? That's a good, probably no. Does anybody know what REST means? Okay, so REST is this idea of representational state transfer. And the basic idea, the one that seems to resonate the most right now is this idea of, the URLs identify resources, and then I operate on those resources using standard verbs. And so you could go ahead and create a custom REST API for something, a little bit like what Facebook and Twitter have done. The problem is it's like the honeypot effect, right? The only way that people are going to know how to talk to your service is if your data is compelling enough that they're prepared to invest in learning your custom API. So good luck with that. So what does OData give you then? So number one is it's simple. Like if you want to consume an OData exposed via OData in JavaScript, it's trivial. Okay? If you want to get it into Excel, there's a plugin to Excel that does that. And that's actually, I think that's going to be mainstream at some point. We extract the data store, so it doesn't really matter what data you actually have, so long as you can look at it through the lens of OData. Okay, so you could have a triple store under the hood if you're familiar with RDF, for example, and you could expose that with OData if you wanted interoperability with, say, Excel. We support arbitrary data access, and this is kind of a key one. If you went ahead and created a SOAP-style service that people could interact with to get data, the problem with that is that you have to think in advance and you have to know in advance what people are going to want when they're talking to your data source. They're like, oh, they're going to want to get elements by type. So I'll create a SOAP method which allows me to get the elements by type. But then, it goes out into production, and you've got this data source out there, and then the first thing you get is a call from someone who says, no, I want the elements by atomic weight range or something. And you can't. That's where OData, it comes in. The flexible query language means it's suited to dealing with data. Now, perhaps the most important one, or the one that I think is the most valuable for OData, is that we actually have an ecosystem of platforms and devices and language, which languages means as soon as you publish your data as OData, anybody on any of those platforms or devices and in any of the languages that OData supports, which is a broad range, can now talk to your data source. And as a side effect of that kind of broad range of things, there's actually a load of big adopters, right? So SharePoint, SAP, Azure, Microsoft CRM, SQL itself. These are just some of the examples of people that are pushing their data out using OData, which means there's a crowd of developers out there that know how to deal with OData, and you can kind of leverage that. Yep. Okay, there you go. Which services did you say? Sorry.
The storage services, cloud storage services.
Okay. Yes.
Okay.
Yeah. Okay. So the question is, how does OData relate to the other offerings that Microsoft has for REST services? So I think it's fair to say that Microsoft is slowly moving a lot of its services to OData. And there's, if you look at that list there, that includes a lot of them already. And so OData is becoming sort of like a de facto standard for the way we expose data. It's not an official standard, it's just the de facto at this point inside Microsoft. So you'll see more and more people doing that.
So new projects that expose the storage services do not really use the native REST services exposed by storage service but start using OData as an wrapper on it?
No, I'm not going that far because there are good reasons sometimes to use a particular library or a particular API. Maybe OData doesn't support some of the things that they need or you need in that particular scenario. So it's sort of a case-by-case basis. Maybe we can talk offline about that. So there's lots of different ways of producing OData today with Microsoft, with the Microsoft stack, with external third parties. There's actually examples of, for example, what's the correct word for this? Content management systems. A number of content management systems now expose their data through OData. But here's kind of three that I kind of want to talk about today. The bottom one there, Data Explorer. Assad is going to be talking this afternoon, I believe, about Data Explorer, and that actually is a really great way to kind of take random data sources and kind of compose them together and produce kind of, what's the right word here? I'm looking for the word, what's that? Well, mashups, yes, but it's almost like, no, aggregated's good too. These are good words. What is it that someone who owns an art gallery does? What do? What's the right word? Curation. So maybe I want to curate my data, right? I'm pulling together this data, mashing it up, and I'm pushing it out, and that's the data that I think is going to be interesting to my people. Okay? So Data Explorer is great for that kind of thing. Mashup, curation, and so on. Mm-hmm. Maybe you kind of do as part of that, as part of exposing the data, you're actually removing some of the inconsistencies in that data, some of the holes in the data, because when you're consuming data, part of the problem is dealing with that dirty data, right? OData lib is a new library that we've been working on that actually is now actually used in the guts of WCF data services, and it's a low-level API for creating and consuming OData payloads. Okay, so you can use that to create a feed if you want to. It's a lot of work actually, but it gives you the most control that you could possibly have. Okay, then the one that I want to really focus on today is WCF data services, which is where that was originally called Astoria. It became ADO.NET data services, and then now it's WCF data services. So we went through the same kind of naming journey as the Orinoco /Stream Insight / whatever team as well. And that thing supports kind of three primary models, three things that it can sort of expose. It can expose relational databases by using the entity framework. So if the entity framework has a connector for the relational database, you can expose that through WCF data services as OData. We also have a connector for just like .NET classes. I'm writing .NET classes, and I want to expose the data in those classes out to the web. I can do that with what we call our reflection provider. And then finally, you can write a custom data provider. That's a little bit more work. It's basically a set of interfaces that are already implemented for you here and here that you can implement yourself. And if you do that, you get sort of access to, you can access almost any data source at that point. So you could create a custom data provider that maybe exposes RDF triples or something. Okay? So let's go ahead and actually try creating an OData thing. What I've got here is an Excel well, it's actually a CSV file that Jan gave me. And as I said, it's just some elements. And you can see I've got a number of different columns. And the reason why I did the split here is I wanted to kind of show some of the characteristics of the data. Because what I want to do is I want to get this into a database so that I can maybe turn it into part of a bigger model, or maybe and support better queries across this thing. I don't want people to just have to pull down the CSV file every time they want to know about oxygen, right? That's unfortunate. That's where OData would come in. You can actually issue a query and say, I just want to know about oxygen. But if we look at this, if I'm going to model that as a table, what would I do? I look at this and I can see here that it looks as if every row in that table has a number, a name, a symbol, an atomic weight. But I can't say the same thing about melting point, boiling point, density, crust, and so on. So that implies some things about the database constraints. So if I look at, so what I did then is I went off and created a database table called elements. And if I have a look at the design for this thing, you can see here I've actually made the symbol the primary key. That's unlikely to change. The name of the symbol for the element is unlikely to change in this example. I've got a name, a number. I've got melting points and so forth. And I've marked some of them as allowing nulls because our data just doesn't have that information. I've also gone off and if you look at this, I've said this is a decimal 18.4. And what that actually means is it supports four decimal places. Okay? And the reason why I picked that is because when I was looking at this data, that's the maximum number of decimal places I have in my data. So I'm kind of matching my data source with what I'm storing in the database. So once I've done that, if I run a little query over the top of this, I've got no data in the database right now. The next step that I had is I created a little project. And you can see here this is an entity framework model. Okay, and this entity framework model, I just generated this straight off the database, and I can show you how easy that is by adding a new one. I'm not going to use the new one, but you'll get to see the experience. So I'll go ahead and create an ADO.NET entity data model, and I'm going to say that's actually the entity framework. Okay, and I'm going to say let's call this test. Let's choose a number which I know I never will have done before. Random number there. And I'll generate it from the database. And I will choose this chemicals database, which is where I got it from. And I'm going to give this another name. Hit next. Now it's going off to the database, looking at the tables that are in there. And gives me an option to choose which ones I want. So I want just elements. I don't want my backup. That's just in case anything goes wrong, right? So, I'm prepared. That's my famous last words, right? Touch wood. So if I do that, and now I've got another thing which looks exactly the same. Okay, so that just shows how easy it is to create this thing, right? I don't need that though. I'm going to delete it. If you look under the hood here, you can see that this thing has gone ahead and generated two things. It's gone ahead and generated a context, which is called chemistry entities. That is kind of acting as my data source. So think of this as a kind of a strongly typed database. Okay? And that thing has got some properties on it. It's got this thing called elements, which is what I'm going to interact with to create new element entries in that table. And along with that, it went ahead and created this element class too. So that's one of these entities down here. And you can see it's got a whole lot of stuff in here to do with code gen, which most of the time you would never see. But it means that I have a class that I can interact with that represents an element. And now what I did was I went ahead and wrote some code that simply creates a new copy of that database, that's essentially that database, right? It's not creating a new copy, but creating a connection to it, right? Then I said, okay, well, I'm gonna go and open the file, okay? And I'm running in the bin debug directory, so I had to kind of dot up a couple of levels to get to the elements CSV file. Then I open that as a stream with a stream reader, and that really just means I want to read it as characters instead of bytes, okay? And the reason why I want to read it as characters is because I want to just read lines, because I know this is a comma-separated file. So the first thing I do is I just go ahead and skip the header row here, right? I don't care about that. I know what I'm dealing with. I just want to read the data. And then I wrote a little method to go and read all the lines from that as an enumeration, so I can enumerate through the lines in that file. And for each of the lines that I come across, I call a method here called create an element for that line. And if we look at the way that code works, it's pretty simple stuff. I take the line, I split it on commas because it's comma separated, right? And then I pull the different property names of the element object from the different parts of that, the different elements in the array that got generated. And you can see, some of these things need to be there. Like I need to be able to parse the atomic weight. That's because in the database I said that's not nullable. Okay, every row in that CSV had an atomic weight, so I better be able to turn it into a decimal. Then some of them, though, like the melting point, I've got some code here which says, well, if you can't convert that to a decimal, give it to me as null, because I'll put it into the database as null. So I got all this data. I've converted a line of the file into an element, and then what I'm doing with that is I'm adding it to my database. I'm adding it to this collection called elements, and so the entity framework is kind of remembering what you're doing here, okay? And then finally, right at the end, I go save changes. Now, this code works because I've only got 109 rows, right? Entity framework would not be useful for dealing with like, a million rows. You wouldn't attempt this. You'd either have to split it up or you'd use a different way to get the CSV file into the database. Now, there are lots of easier ways to get CSV data into a database, but I did it this way because I'm going to leverage this entity framework context in the future. Okay, so it's kind of like this is kind of killing two birds with one stone. So now if I just bring this up again. I should just be able to debug this now. Oh, lovely. Oh, yes, this is a bug I've seen before. What's happened here is I'm trying to open a file which is already open. So it doesn't like that, so I just need to close my Excel file. Don't save any changes there. And we will, let's restart. Whoops. So now I've got my rows in my database. And we can see that by rerunning this query. And there we go. You can see they're ordered by symbol because that was the primary key I chose. So I've got my data in there now. Okay, so how do I now, so that's kind of step one, get that data somewhere where I can easily expose it. Step two, I've got this website project. It's essentially an empty project. I've cheated a little bit. I put one file in there, but I'll show you why later. So trust me, this is kind of like I created an empty website. Okay? The only things I've done is I've added a reference to my other project. Okay? So that's so that I can gain access to this guy. Because I'm going to use this when I expose my OData. The way I do that is right-click on here. So I want to add a new item. And I want a WCF data service. And I'm going to call this chemistry service. And what this does is the chemistry service is a stand-in for an OData service. Okay? And it asks me, hey, what's your data source? Now this is where, as I said previously, you've got kind of lots of options with WCF data services. The easiest one is to use the entity framework. That's what we've got. we've got a chemistry entities which we can use. And it came from the data loader service, so that's why I had to kind of use data loader. So this is saying, hey, create an OData service using that data source. So far, this wouldn't actually do it. If I ran this code, it wouldn't actually do anything, because when you're doing this, you have to kind of explicitly decide what you want to expose. So I'll go ahead and do that. What I want to do, oops. I want to set an access rule that says, hey, my entity sets, because this is kind of like I don't want people modifying the data through this service. I just want them to be able to read it. In this particular example, I'm just going to say all read. So that means every collection of data that you have in that data source, I want to expose it as read. Now you can go through and individually call out the things you want, but we don't really have time for that. The other thing I want to do is set an entity set page size limit. And again, you can do this per set, or you can do it for every set. So I'm setting it to 10. Now, what this actually does is it says, hey, if a request comes in from a client to get data, don't give them everything. Give them a subset, because often the person is not wanting everything. So like when I hit a service, and let's say I'm rendering it in a UI, I didn't really want all 100,000 rows in your database. I just wanted the first 100. Okay, so in this example, it's a good idea to put page size limits in. We typically recommend something between 100 and 500 as a good size, but because we've only got 109 rows, I'm going to put that down to 10 just so we can see this in action. With that in place, I should just be able to run my code now. And there's my OData service up and running. Now, if you hit the root of the service, you get an AtomPub, an AtomPub service document, which tells you what's available. But this thing's kind of pretty bare bones. It only says that there's a feed called elements. It doesn't tell you anything about it. $metadata is kind of the thing I was talking about previously. That tells me a little bit more, right? This thing tells me that I've got an entity set called elements that's of the type element, and then I can look at this thing and go, here's what an element has. And I can see that the key of an element is its symbol, and a symbol is a string, and like it's got an atomic weight, and that's a decimal, and it's accurate to 4 decimal points. And so that's kind of cool. So with that knowledge, I can now actually start making requests. And you can see here I just hit elements. And if I kind of close all these up, you'll see that it should have only returned the first 10. And what it's done is it's put in a next link there that says, hey, if you want more of the data, just go and follow that link instead. So I could just cut and paste this guy, put it up here, and then I get the next 10. I could also ask some more interesting questions. I know that the primary key, or the key of the elements, is the symbol. So if I wanted gold, and I know the symbol for gold, then I can just pull back gold. And if I wanted to know the atomic weight of gold, I can pull that back too, right? So like now I've got the ability to kind of query my service. I can also do some more interesting things too. I can say, hey, I want to do a filter here, and let's say I want all the elements that start with, where the name starts with, let's say HE. I've only got one, but you can imagine that I can write queries here that pull back just the data I'm interested in. Okay? And I can also do projections, so I can filter the data I'm interested in. Well, not filter, I can narrow what I'm interested in. So I don't get all of those pieces of data. I don't care about the boiling point and the density. All I care about is the name, the symbol, and let's say the year of discovery. And now that's all the data that's returned. Okay? So this is, I'm showing you this with Atom, but I've actually got another example in here. I've got this little HTML file which uses jQuery, so that means it probably wants to use JSON to get the same thing. And it's just pulling that data down. Very simple. And it follows the next link. And I can just see all my data. And the code for that, if you're interested, is very simple. Standard bit of jQuery code. So I've just got a div where I'm going to put my results. I've got a button called Get Results. I've got some anchors, which I've got a class on them called Intercept. So anytime any clicks that anchor, I'm going to intercept it and do this instead. And I'm going to just pull the href out and get the data from that href. I've got a function which actually goes and gets data. And all it does, it calls the JSON, the built-in jQuery getJSON method, and takes the URL, issues a request, pulls the data down, and puts it into a table. And then if there's a next link, so if there's one of these guys, it creates an anchor which says more, and then it puts the class on an intercept so that whenever that thing gets clicked, my other event handler gets fired. And that's pretty much it. And then, the first time you click Get Results, it just calls, hide the Get Results button so you can't click it again. And then it just goes and gets the starting point. Okay? Pretty simple code. Every jQuery programmer in the world could write this code, right? Well, that's a big, bold statement. But let's say every competent jQuery programmer in the world could write this code. Okay? So that's my quick demo of creating and exposing an OData service. Let's go back to the presentation. How much we've got? We've got about 4 minutes, so this is going to be quick. So some new things in OData v3. The first one that I think this audience is going to be very happy about is spatial. We have now got spatial types. So you don't have to model your spatial types in random ways, right? There's a standard way to do it. You've now got some OData originally shipped with a load of primitive types, integers, booleans, decimals, that kind of thing, date time. We now add 2 new hierarchies of primitive types, geography and geometry, and they both have like point and line, string, and all the things that you'd probably used to. I'm not an expert in that, but I can point you at the people who are. So if you want to know, let me know. But in this particular example, I'm imagining I've got an OData service which exposes catchment areas, and I want to pull back all the catchment areas that are close to some location. And so what it's saying is that I'm calling the geodistance function, and I'm saying, hey, the location of the catchment area, the distance from that and this geography point is less than something, right? I may have got some of this format wrong, but I can point you at the guys who know what's going on. Another thing we've added is actions and functions. So actions are things that are kind of side effecting, but fall outside the norm or the kind of the uniform interface of OData, which is like insert a single item, get a single item or get a collection of item, update a single item, delete a single item. This allows you to do more interesting things. So, for example, here I'm saying catchment area 5 has got a new day's worth of telemetry data or something, right? And it's actually stored in this CSV file. And I want you to go ahead and process that and put it into the database so that people can then query it again later. Okay? Likewise, on the other side, so that's actions. They're kind of side effecting. They change the data source. Functions, on the other hand, allow you to modify the kind of the URL structure for queries. And they allow you to change how you query the system. So I added a function here called which meets some criteria, right? It could be any name there, and that thing could take parameters. And the idea is that it gets composed directly into the URL, allowing you to take any OData URL and then compose the function call with that. These two are pretty exciting, I think, as well. So any and all. The first one here is saying, I want to get all the catchment areas which had any temperature greater than 110 degrees in whatever, in some time period, right? Like, depending on how much data we've got, right? The next example is saying, I want all the catchment areas where all of the temperatures were less than, below 0, right? So these are kind of two new things which just increase the queryability of the OData stack. We've also added some other things, better inheritance support, support for patch, prefer. If you've got any questions about these things, just come up and ask me. So, look at that. I think I was pretty close to being dead on time. So, in terms of a conclusion, you can see, I think, that using OData is a great way to kind of take that data, which maybe you've got in a CSV file or some random data source, and expose it to the web and let anybody consume it. Excel, clients, JavaScript applications, Windows Phone, iOS, anything. V3, another thing we didn't spend a lot of time on this, but V3 of OData is much better for eScience. We've got spatial stuff, we've got actions and functions which allow you to do some things which are a little bit outside the norm, but provide the extra power you need. And then of course, perhaps the most important thing is that when you use OData, you're getting into an ecosystem of tools and things which will make it so that anybody can connect to your data. I've got a series of links here. OData.org is where you can find out about how OData is changing. We do most of our design out in public, so that's pretty good. We've got the environmental informatics framework, which Jan and Dan have worked on, and that's very cool. WCF Data Services, that's what I was just showing you before, and then a whole list of other things. Don't worry about copying these down. I'm sure Jan will share the deck at some point. Any questions?
Thank you. With Alex.
Yep. No questions? This always happens. It's like stunned silence.
I know we're all here for the beautiful, glorious data visualization tools. Those are always more attractive.
Yeah, this is more low level. This is kind of like where the rubber hits the road, right? Yeah, absolutely. So do you want to take that one, Mike? Because the question was, do we use this with SQL Azure?
Oh, here.
It's okay. I know you're the expert in this, though.
So the question is, can I use OData with SQL Azure? The answer is yes, absolutely. Alex showed the entity framework exposing a model on top of regular SQL Server, on-prem SQL Server, and then built an OData service over that. You can do exactly the same thing using SQL Azure, and you can expose your own custom model. We also, for a while, had in SQL Azure Labs a prototype of a product that would automatically expose OData on top of your SQL Azure database. So as you modified the SQL Azure database, modified the structure of it, whatever you exposed through the user that you had provisioned for your OData service would automatically be exposed as an OData service. And if you guys have interest in that, I'd be happy to talk to you about that as well.
Any other questions? Yep. Okay. Do you know this? Yeah, this is a good question for that.
There was actually a question earlier about REST interface to storage and Windows storage. And the Windows Azure table storage REST interface actually is an OData interface. They actually use WCF Data Services in order to expose it, and they write what we call a custom provider. So when you're using that REST interface, whether you know it or not, you're actually using OData.
Thank you. Our photographer is waiting outside, so let's keep talking as we follow Jaya outside, and then let's have a group picture taken.